Hello, my name is Fernando Ramos. I am a professor at the Department of Computer Science of the Faculty of Sciences of the University of Lisbon, and also a researcher at the LASIG research unit. And in this video, we will demonstrate Sirius, which is a multi-cloud network virtualization platform that we developed here in our team in the context of an European H2020 project called SuperCloud. So this was joint work with Max Alaluna, my PhD student, Eric Vial, an integration engineer, and also Professor Nuno Neves. So Sirius improves over existing network virtualization platforms by enriching the substrate network with resources from multiple clouds, both public clouds and private data centers, and also enriches the virtual networks with security and dependability. Sirius uses a software-defined networking approach to achieve these goals. To give some context on the demonstration, so we have set up a substrate infrastructure composed of 3 clouds. So that's one public cloud, Amazon EC2 running in Germany, another public cloud running in Google Cloud Platform running in Belgium, and also our private data center here in Lisbon at the Faculty of Sciences. So Sirius takes advantage of this multi-cloud substrate in order to provide virtual network services that are enhanced with security and dependability. In this demonstration, we will show 2 different users, 2 different tenants, making use of our Sirius multi-cloud network virtualization platform. So the first is Max Data Virtual Network. Max Data is a software company here in Portugal that makes information systems for laboratories, for hospitals, and the virtual network of this tenant is composed of 9 virtual hosts. Each virtual host is effectively a Docker container in our architecture. And so we have the virtual network is composed of 2 virtual switches, one connecting Data, which is Max Data's web application and database, and the other virtual switch is connecting 7 virtual hosts, 7 containers running in Hyperledger blockchain. The second tenant that will be using our infrastructure is a tenant from Philips. This is an imaging application, a distributed application from Philips, and we have a web application running in. So we have a different topology, a different virtual topology with 3 switches. One switch is connecting the Philips web application for hospitals, that's Hospital 1, and also another container with the authorization service 1. Then a second switch for Hospital 2, so with a container for Hospital 2 and a container for the authorization service 2. And finally, we have a third switch that's connecting Llanos Storage. Llanos Storage is also a multi-cloud solution for storage that was also developed here in our department in Lisbon. Effectively, Llanos Storage stores the data across multiple cloud services. In this case, Amazon S3 in Germany, Google Cloud Storage in Belgium, Microsoft Azure in Netherlands, and IBM Cloud in the UK. So the main takeaway from this demonstration is that we are running a complex multi-cloud substrate composed of 7 cloud services using 5 cloud providers across 5 countries and running 2 non-trivial virtual networks with different topologies. Now we will start a demonstration by first visualizing the substrate infrastructure. So as I said, we have a substrate composed of 3 clouds. The yellow elements are basically 2 virtual machines that are running, that have 10 containers ready to run each. These yellow machines are in Amazon. Then we have one virtual machine in Google Cloud platform. That's the red one. So we have one virtual machine with, in the center we see the software switch, which is Open vSwitch, and we have 10 containers also. And then the blue one is our private data center, a virtual machine running in our private data center at Lisbon, again with 10 containers ready to run. And you can see a particular element at the bottom left called the controller. That's basically our network hypervisor, our multi-cloud network hypervisor Sirius, which is running in Lisbon. So in summary, 4 virtual machines deployed in 3 cloud infrastructure, with each virtual machine running with 10 containers pre-configured. And so we will now make the first action, which is log to the orchestrator through a browser. Okay, so now we will log into Sirius. So on the left, you see the substrate infrastructure. So this is what the administrator of the system views. So we have set up 4 virtual machines across 3 different clouds. So in yellow, we have Amazon cloud, 2 virtual machines. In the middle of the virtual machines, in the middle of the figure, you have the Open vSwitch and the 10 containers around it. So Google Cloud is set in red, so you can see a virtual machine in Google Cloud and a virtual machine in the University of Lisbon, the blue one. So we have defined different security levels for each of these clouds. So we set up the security level for Lisbon, for the blue node, to be highly secure, a highly secured cloud. The yellow cloud, which is Amazon, we set for secured cloud, so it's a level of security that it's a bit below secured cloud. And finally, for Google, it's default cloud, so the lowest, let's say, level of security. Okay, the second step is to create the first virtual network from the first tenant, that's MaxData. So I recall that MaxData's virtual network is composed of 9 containers, the Clinidata web server connected to a Postgres SQL database, and this is connected to another switch, another virtual switch that's running the Hyperledger, which is composed of 7 containers. Now we will import MaxData topology from a file. Okay, so now we will open MaxData's virtual topology. As we see here, 2 virtual switch interconnecting 9 virtual hoster containers. Step number 3 is the configuration of MaxData virtual network. So for each container image, we will set 2 different attributes, namely the cloud security level. So different clouds have different security level in our infrastructure. And we will also set up IP addresses. So as explained before, we have a highly secure cloud, a secure cloud, and a default cloud. The highly secure cloud is Lisbon, the secure cloud is Amazon, and the default cloud is Google, just to recall. So the Clinidata web server, Tomcat server, is set with IP address 10.0.1 to a highly secure cloud. The same for the Postgres database with a different IP address, of course, 10.0.0.2. And Hyperledger will have 7 IP addresses across the range 10.0.0.3 to 10.0.0.9, and it will be set towards a default cloud. So now we'll check containers configuration. Okay, so now we will check the configuration. The Tomcat web server, that's MaxData's application with a virtual IP address 10.0.0.1 and a security level of highly secured cloud. And for example, the Postgres database 10.0.0.2, also to a highly secured cloud. And finally, for example, one of the containers of the blockchain with an IP 10.0.0.6 and set to a security level default cloud. Step number 4 is to deploy MaxData virtual network. So when we deploy MaxData virtual network, what will happen is that a request will be sent from the orchestrator to the hypervisor. So our Sirius is composed of 2 these two components, which is one is the orchestrator, which takes care of the compute part, takes care of managing the virtual machines of the substrate, etc. And then we have the hypervisor, which effectively ensures network virtualization. And so a request is sent from the orchestrator to the hypervisor, and then the hypervisor will run two main functions. The first is a virtual network embedding. That's basically mapping the virtual network request into the substrate network. So we have an algorithm that's very fast to perform this embedding while complying with the requirements of users and the constraints of the substrate in terms of the resources available, for example. The second step is to install flows in switches. So we want to assure connectivity of the virtual network. So the hypervisor has also to provide this while guaranteeing isolation between different tenants, of course. And finally, the orchestrator deploys the requested images on the remote VMs. So from these three functions, the first two are very, very fast. The third is the one that takes more time because you have to deploy the requested images on the remote virtual machines. You have to configure each container, to be ready to run the distributed application. So this is the step that takes a bit more time. So it's not so much the networking aspect, it's more, the setting up and configuration of the containers. So we'll now send the request to the hypervisor. Now we will deploy the virtual network onto the substrate. So three things will happen: embedding, configuring the flows, and then setting up the containers. Those are the three steps. Okay, so Max Data's virtual network is deployed. Let's check, for example, if all requirements were met. The Tomcat web server, which had to be in a highly secured cloud, went to the blue cloud, which is the Lisbon private cloud. So it's a highly secured cloud, as we can see here. And the blockchain went to Google Cloud Platform, which is set as with the security level default, as we wished. Very good. Step number 5 is to check the connectivity in Max Data Network to make sure that everything is working as wished. So we will ping to test the connectivity between Tomcat and one of the containers of the blockchain. And you will see high latencies, or relatively high latencies, due to the fact that these containers are in different clouds. So we will have to cross the internet, so the latency will be relatively high. Then we will also ping between Tomcat and Postgres, the database. They are in the same cloud, so you will see low latencies. So this is the next action, testing connectivity. Okay, so let's test the first. Let's try to ping from the Tomcat container to one container from the blockchain, 10.0.0.5. And we see here that indeed the ping was successful, so we have connectivity. And note that the delay is relatively high, 62 milliseconds roughly, because this is crossing the internet. So this is in two different clouds. Now we will do the same, but for the Postgres database. And we will see that in here, again, connectivity. We have connectivity, but we only have less than 1 millisecond of latency because they are in the same cloud. So far, so good. So Max Data's virtual network is running on top of Sirius. And now we will create Philips virtual network. That's the second tenant. We have two web servers, one running in Hospital 1, the second in Hospital 2. Two authorization services, one for each hospital, and then the Yanos multi-cloud storage service. So let's import the topology from a file. Okay, so now let's open the second virtual topology. Now from Philips. So Sirius indeed is a multi-tenancy solution, and so we have a second tenant with a different virtual topology, so we can have different virtual topologies, arbitrary virtual topologies, and in this case we have three switches and 5 virtual hosts. Now we will check the configuration of Philips virtual network. So again, we'll have to set the cloud security level and the IP addresses. And we will set them as follows. So for Hospital 1, we will set the IP address 10.0.0.1. Note that we're using the same IP address that's being used in MaxData's virtual network, which is okay because with Sirius, the tenants can use whatever IP addresses and Ethernet addresses, in fact, that they wish. So this is all virtualized. So we will set Hospital 1 and Authorization 1 service to a highly secure cloud, Hospital 2 and Authorization 2 to a secure cloud, and finally Janos to a default cloud. So let's check the configuration now. Now let's check the configuration. For Hospital 1, we have the IP address 10.0.0.1. Note that it's one IP address that was already used in MaxData's virtual network, so we can reuse virtual IP addresses and also Ethernet addresses, in fact. And this is set to a highly secured cloud. If we now check for Hospital 2, or authorization 2, the configuration, so 10.0.0.2, that's the virtual IP, and to a secured cloud. Finally, Janos is set to a default cloud, 10.0.0.4, the IP address, to a default cloud. Okay, now we will deploy Philips virtual network on top of Sirius. So again, the same will happen as with MaxData's virtual network. The request will be sent from the orchestrator to the hypervisor, then embedding will run, installing flows and switches, and deploying the requested images on the remote VMs. So let's send a request to the hypervisor. Now we'll deploy the virtual network. Okay, so Philips network was deployed. As we can see, the requirements were met. So Hospital 1 is in the blue cloud, which is a highly secure cloud. Hospital 2 in a yellow cloud, that's Amazon, that's our secured cloud. And finally, Janos is in the blue cloud, which is Google Cloud Platform with a default security level. Now let's check connectivity to see if everything is working well in Philips network. So we will again test connectivity now between Hospital 1 and Janos, and we will see high latencies again because this is crossing the internet because they are in different clouds. Then we'll make a similar test but between Hospital 2 and Authorization 2, and we will see low latencies as they are in the same cloud. So let's now test connectivity. Okay, so let's check connectivity now from Hospital 1 to the Janos, the cloud service, 10.0.0.4, and we see there is connectivity and the latency is relatively high because it's crossing the internet. Now we will try to ping from Hospital 2 to the authorization service of Hospital 2. And indeed, we also have connectivity and the latency, it's much lower, less than 1 millisecond because they are in the same cloud. Okay, so we've seen that there is connectivity in the two networks of the virtual networks, but we want to assure that the virtual networks have the experience that they own completely the infrastructure. So we have to guarantee isolation between tenants' virtual networks. So for this purpose, we will ping between Hospital 1 from Philips network in tenant 2, so Philips network, and we'll try to ping an IP address that's not present in Philips virtual network, but that it is present in MaxData virtual network. That's one of the containers of the blockchain, that's 10.0.0.9, and we will see that this will fail because Sirius guarantees isolation. Let's check this. Okay, so now we'll test isolation. And we will try to ping from Hospital 1 to this IP address that does not exist in Philips virtual network, 10.0.0.9, but it does exist in Philips virtual network, in MaxData's virtual network. As we can see, the host is unreachable. We can check now in tenant 1's network that we had an IP address 10.0.0.9, in fact, it's here, but it's not present in tenant 2. So as we wanted, we are showing isolation. Okay, now that we have finished demonstrating that everything was correctly set up and seems to be working fine, now we will very quickly show the two applications that are currently running on top of Sirius. So we will start with CleanIData, which is MaxData's laboratory information system that uses our multi-cloud network virtualization platform and also our multi-cloud storage, Janos. Okay, now we will demonstrate CleanIData. So we will enter as a doctor into this application, and we will first try to find an order from one patient. That's the first step. So this information will be retrieved from the blockchain. So this was information already added to the blockchain. And now we will update one of these fields from the patient data. So changing, this is a doctor changing the glucose level, for example, for a patient. And now we are saving this into the blockchain. So the blockchain has to run the consensus protocol. It takes some time. And after that, the order is updated in the blockchain. The second tenant is Philips, and Philips has this distributed application, which is a medical imaging platform, which we will now demonstrate again very briefly, just to make sure that everything is running correctly across using Sirius. And now we will check the application of the second tenant, Philips. So we'll enter again as a doctor, Dr. Andrew. We are entering the system. So this application basically shows X-ray information. So in here we will open one of the files. We have files from several hospitals. So these files are stored in the Janos multi-cloud storage system. We're retrieving these images from these 4 clouds, and indeed this is one example of one picture. Okay, to finalize the demonstration, just a quick summary. So we've shown a demonstration of Sirius, our multi-cloud network virtualization platform. Sirius, we've shown Sirius running with a substrate that spans 7 clouds, that uses 7 cloud services from 5 different cloud providers and spans 5 different countries. We've shown 2 real applications running on top of Sirius, and have shown that also guarantees the required isolation between tenants. We hope you've enjoyed the video. Thank you very much.